Hello YouTube, welcome to my video blog. I'm your host Philip Meyer, and yeah, as you know, I finished repairing my Robotron a5120 monitor. And now it's time to put the monitor back into the computer itself and see if the computer is doing anything at all. I'm already excited if it will. We just start with some basic checks like checking the power supply voltages and stuff. And yeah, let's go down to the laboratory and see what we can do. So in order to check the power supplies, I plugged out all the boards and all the floppy drives to prevent possible damage in case something awful happens. So what I will just do, I will just plug the cord in and try to start the machine up. So I plugged the power in, and what you can see here is the voltage indicator board, which basically tells you if your power supply is working correct or not. This is a diagnosis board basically, and the first two LEDs just tell me that the standby power supply is running. So as I might mention in my previous video, this machine had a some kind of a more or less intelligent power supply, like you know it from the modern PCs. You just press a button and then the machine starts, which we can do now, and it could be shut down, software controlled and whatnot. So I hear the fan spinning. So now the fan turned down. That's also like normal, like you know it today. The fan adjusted speed, so not very common in these days. Okay, so one of the LEDs not lit. When I understand the documentation on Robotron technique right, these are of course the standby power supply LEDs. This is for the main power, and this is for the voltage regulator module. There's another additional regulator module. I think it sits right there, or maybe this is it. I don't remember. Yeah, that looks pretty much like the voltage converter board, and I can hear a little hum coming from there. So these voltage converter board was responsible for the negative voltage, plus and minus 12 volt, and these seem to be okay. So one of the main power supplies doesn't work, and if you tap it with your finger, you see it's coming up, and now it's on. So there's definitely a contact problem. So we have to work on that first, and when we have that resolved, we can move on measuring the voltages. So I'm using these pressurized air in spray cans. This is not even air, it's just a gas. So this will take me some time. So I can gain access to the power supplies by just loosening two screws here and one underneath here and one in the middle over here. Then you pull this off, and by the way, notice you can determine the power supply type here by this window. This is beautiful. Not too easy to take off with only one hand. So, and this of course is real beauty of over-engineering again. Yeah, can just pluck them out. They come out just like this. So, but don't confuse them. But anyway, so this was the lower slot. Yeah, I think I will just clean that a bit, and then I slide them back in place. So these are the two power supplies. Yeah, very rock solid build power supply. I like that. These are supposed to be switch modes, I guess. They're very small transformers, so it's possible that these are switch mode. Yeah, they are from Zelamelis, which is, if you look it up on the map, it's almost in the middle of Germany, and I guess close to the border between West and Eastern Germany. Yeah, I think I should slide them back in. One word of warning, I mean, it looks just like these are not encoded, and this missing pin here is just missing by accident, so it's likely that you mess it up, and yeah, and to prevent that, I just used a permanent marker to mark these little windows, so I can always be sure that I did it right. So power supply is back in place. Let's see if we still have the problem. Okay. That looks just like it blows some fuse. Okay, it was a circuit breaker. Oh, now it just runs fine. It's probably in these capacitors if they are emptied. It might need some initial jolt of electricity. Never mind. So I don't see any yeah, it's got worse. Why? It tells me that the main power supply is entirely failed, but the plus minus 12 volt converter is running properly, so something is really odd. Yeah, I guess I need to do some investigation here. Okay, let's also take out the meter and do some investigation here, just to get a bit into the stuff and see what's really going on. Because I have the slight suspicion that these two might be for the -5 and -12, and these two are for the main power. That's just an assumption, so might be I'm wrong. And yeah, of course, sometimes things you'll find on the web are not so super clear. So we just go ahead and tap all these connections here on the boards. So these are measuring 0 volts, so they are obviously ground. What do we have here? That's a -12, and yeah, we have one LED lit. So that might be it. So yeah, let's label it then immediately, just to have some reference. Oh yeah, what do we have here? We have a label 12N, so maybe that means 12 negative. So the ground's not labeled at all. Do we find somewhere else some labels? There's a 5N. So that's supposedly the 5 volt negative. And I have -5 volt right on my meter, so that doesn't really fit well into the scheme. But yeah, anyway, what do we have over here? It's another ground. What's this? Oh, that's your 5 volts. It's not labeled at all, so it definitely needs some labels. So things are a lot easier now for me. I just give it some labels, and yeah. So Next thing I want to find out is for what these LEDs here really are. So yeah, I think I need to do some experiments for that. Let's see what comes into my mind. So I pulled this board what sat right underneath here and cleaned it a bit. And according to a picture I found on Robotron this is supposed to be the voltage converter board. So this is where your plus minus 5 value minus 5 and minus 12 volt come from. And yeah, the function of this circuit, maybe this is the standby power supply. We will see. When I power the machine on, of course the negative voltage should be missing. Or it doesn't power on at all, we will see. So this is it, it's running. Yeah, now we will see if our negative voltages are still there or not. Oh, nothing with the 5 volt minus 5 volt rail. Also nothing at the minus 12 volt rail. And now you also know for what these LEDs in the middle are. So these are the ones for the voltages that are generated from this board. And yeah, that was also what caused the contact problems. Maybe we can resolve this by cleaning the contacts, or yeah, maybe it's the problem's already gone because I slided it on and in and out, and yeah, when I slide it back in, then the problem might be gone. Yeah, I think I will just label the LEDs as well, and then we yeah, have a better reference. So since it's very likely we got a contact problem with these connector here, just use a screwdriver to bend these pins a little apart to basically have some more tension on them to make good contact. Board is back in, and ta-da, you have the LED slit again, and let's check the negative voltages just for a little sanity check, and we have nice beautiful 12 volt. This is the 12 volt from the main power, and here we have seen minus 5 volts and the plus 5 volts. So the voltages are all good, I think. So that's really nice. So I think we are pretty safe now to plug in the monitor. As you can see, I can hit here, and here these LEDs are not flickering anymore. So it was definitely a contact problem over there, which is now fixed. So yeah, now the great moment of sliding in the monitor has come. Apparently somebody hit against the monitor like this and bent the potentiometer here, so I think we will try to fix that first. Okay, this is a really game over for now. Yeah, I tried to bend the pin was bent, and I tried to bend it back, and of course it broke. Yeah, but this is just a 10K pot. Yeah, I guess I will have to order them because these thinner pins are not very common. I do not have a 10K handy right now. Yeah. Yeah, I will have to order that, but yeah, I will think I will try the CRT anyway and repair that later. Yeah, the CRT has some coating on it. I think that's supposed to be an anti-reflective coating. Of course, that broke over the time and got cracks. So this yeah, just a thin layer of lacquer. I think I will get some acetone now and clean that off, and yeah, finally clean the surface before I slide it in. And this looks like new. Yeah, almost new, because I don't see anything. I don't know if you see that, but you can see it if you look carefully. These rows here you see here, that's just means that this machine was in heavy use. So yeah, the screen slightly burned in, and yeah, I don't really can't see. Maybe there's some. Oh, I think I can recognize this. Do you recognize this maybe too? You see there's A, B, C, D, E, F, G. Yeah, some other thing. I think that must be some spreadsheet application that ran there. Yeah, I don't know the exact name anymore. VisiCalc probably. VisiCalc was the Western name for that. And I can even see here that's Tag, that means day. And yeah, what is this? SEC, that's seconds. Ziel means goal. So yeah, maybe they had some spreadsheet application regularly running on this machine. Yeah, and that left its footprint inside the CRT. Never mind. I mean, CRT should do just fine, even with that little issue. Yeah, with all the dirt on it, I wasn't able to see it, but now I see the slight burn in. Yeah, just means that this machine had a colorful life back in the days. I think I will leave these cover parts off for now. I think they need a shower anyway, so I will take them with me under the shower to clean them. Yeah, I'm sorry for this offensive thing in the back. Yeah, there will probably some video about it soon. I hope so, at least. So yeah. So anyway, back to the topic. Let's put this sucker back in. So let's see what happens when I turn it on. Yeah, I hear a nice flyback noise. I don't see anything on the screen. It is probably because I turned the pot before I broke it. Yeah. That's not so good, folks. I really like to see some green glow. I fixed the pot with some of these cheap, shitty things here, and now I see a really bright screen. So that's how I like it. And yeah, I think the next thing we should do is we should just put these PCBs back in and see if there's something on the screen. So luckily back in the days I took this photo that shows me how these electronics were plugged in originally, and I think I will just restore what I see on this image. So looks good, I think. The connectors left are only from the floppy, and this hanging out here, which is probably from something on the side that might have to do something with the keyboard, I don't know. But for the monitor test it's sufficient. So yeah, of course. Okay, I hope this time it will do it. Okay, there's nothing. So nothing like, I mean really nothing. Here's a noise from the flyback transformer, but it really doesn't draw anything on the screen. So since I see nothing on the screen, I'm curious what the video board or graphics card, which is over here, outputs, and yeah, or if it outputs something at all. So now let's turn it off. Oops, it's shredding my oscilloscope. I won't see the screen in a comfortable position. So I have my probe here. Yeah, nice. 50 Hertz hum. So now we will need to probe that, which is a bit difficult with the camera, of course. So that's the first, and nothing. Next one. Nothing again, completely dead. Dead as well. Dead. Dead. So it's no surprise at all that the monitor is not showing anything except a black screen. Yeah, I don't know. Yeah, I think it's a good idea to have a look at some of the basic signals like reset and clock first before we move on. So since the machine is completely dead, I thought that it is a good idea to examine some of the basic signals. And one of the first signals you want to probe on any computer that doesn't work is the clock signal. And yeah, of course, this is tucked. And yeah, I found the signal right here at the lower part of the bus. That's where the system bus is. And yeah, luckily the documentation you find on robotrontechnik.de is exactly one-to-one in orientation, so it's not flipped or something. So it's just if you have the tucked the clock here, you can find it on the same side on that backplane board as well. And yeah, on the one pin lower, we should find the reset signal, and I'm curious how that looks like. I mean, the clock here looks, except for the voltage, I mean it's roughly 4 volts, but I think that's okay. So clock is properly generated, but the next thing I want to see is if the reset is properly generated. Yeah, so yeah, I will just wire it to the reset pin now. So for the reset signal, it's of course important that it rises sometime after the power is switched on, so that the electronics have time to get into their stationary state. And yeah, I will just measure it. I hooked another probe to the oscilloscope, which is just connected to the 5 volts, and the blue line is the power supply, and the yellow line is the reset line. And I will now start this up. So stop, and here we have it. And as you can see, the reset signal is going too high after about 150 milliseconds, which is fairly enough. As you can see here, the power is slowly rising. Here it reaches its a stable point, and then the reset is freed, and yeah, the machine is supposed to run. I think that's okay, what I see here. Nothing to worry with. Yeah, so there must be some more subtle defect in the machine. So yeah, I'm trying to find out which of the signals are interesting for the video board, and yeah, surprisingly, I mean, if you 369, so the ninth, that's your clock, and yeah, if I count it here, 3, 6, 9, I don't see any trace there. On the other side, I don't see it as well, so this doesn't use the clock, and also the reset doesn't use it at all. Yeah, and then later you have your address bus and some read-write stuff, and yeah, mostly for the data transfers. But there's two signals I want to look at in this video at least, and that's the this ready signal here. These are the epsilon, and this halt signal. Right now I don't know for what they really are, but this ready thing, yeah, could be something for the bus. It's a bus ready, but it could also be something from the power supply that says that it's ready now. I don't know. But this ready signal that's used, and the halt signal, let's check that. That's 1, 2, 3, 4, and if I count this node, this is the other side, so it's on the side, so the fourth signal that's not even connected, so the halt signal is out. Yeah, it sees it's ready, and refresh then. Here, these two, that's number 5. Yeah, these are number 5 here, if I count from the top, and yeah, I think these are the two ones I want to look at and just see what happens. And yeah, let's just try it out. Yeah, I'm on the ready signal here, and it appears to be something like that, like a power supply ready indicator, and probably it's just wired to the 5 volts of the power supply. As you can see, the voltage building up here. I don't know what this is, but yeah, anyway, yeah, I don't know, I'm not really happy with this burst of noise, but that cannot really be it. So here, now I'm doing this RFSH refresh signal, and it looks like this. I mean, yeah, there are these, it's all a bit noisy, I don't know. So since I'm starting to run out of ideas what else to check, I think I will close this now, and yeah, and go back to the internet and Robotron Technik forum, ask some questions, try to get some knowledge, and then we will see. But yeah, before I say goodbye, I just want to demonstrate one of these nifty features this machine has. I mean, I mentioned this RTX style power button here, and it's constructed in a way, if you press this button 3 times, then the machine is shutting down, and I will do this now, and so you can see it. 1, 2, 3, So this little cracking sound was the switching power supply turning off. So the machine is now shut down, and yeah, I say take care and goodbye. See you next time.